opening with epic orchestral music that fades into a more thoughtful ambient score. Narrator, VO. For as long as we have been human, we have looked up at the night sky and asked the great questions. Where did all of this come from? What is our place within this incomprehensible expanse? The search for answers has taken us to the edge of the observable universe, to the very moment of creation itself. But there is another universe, one we carry with us every moment of our lives. It is infinitely complex, strangely familiar, and yet, in many ways, even more mysterious. It is the universe within the 3 pounds of matter resting between our ears, the source of every thought, every feeling, every question we've ever asked about the stars. These two domains, the cosmic and the conscious, hold what many physicists, from Stephen Hawking to Michio Kaku, consider to be the 2 greatest mysteries in all of science. On one hand, we have the puzzle of the universe itself. Our best theories, from Einstein's space-time to the standard model of particle physics, are magnificent achievements. They describe the world we see with stunning accuracy, but they only describe about 5% of reality. The other 95%? It's a ghost, a combination of so-called dark matter and dark energy that governs the shape and fate of every galaxy, including our own. We know it's there because we can see its gravitational effects, like wind rustling leaves. But we cannot see the wind itself. We have built a map of the cosmos, only to find that most of the territory is labeled "Here be dragons." Then there is the second, perhaps even more profound mystery: consciousness. How does a physical system, a collection of nearly 100 billion neurons firing in a dark, silent skull, produce the non-physical experience of being you? How does the chemistry of the brain create the beauty of a sunset, the sorrow of a loss, or the sheer wonder of contemplating the universe? This is what philosophers call the hard problem. Science can map the brain's activity, but it cannot yet explain how that activity becomes subjective awareness. It's the ultimate magic trick, happening trillions of times a second inside every one of us. For centuries, we have treated these as separate questions, tackled by different disciplines, astrophysics and neuroscience. One looks out, the other looks in. But what if that's where we've been going wrong? What if these 2 great enigmas are not separate at all? Some of the world's most brilliant minds are beginning to suspect that the universe and consciousness are not 2 distinct problems, but 2 sides of the same extraordinary coin. They are asking a radical question. Is consciousness merely a fleeting biological accident on a lonely planet? Or is it something far more fundamental, woven into the fabric of space-time itself? To solve the puzzle of the cosmos, perhaps we must first solve the puzzle of the self. The journey to an answer will challenge everything you think you know about reality. It is a quest that blurs the line between the observer and the observed. A story that connects black holes to brain cells, and the echo of the Big Bang to the spark of a single idea. The 2 greatest mysteries are waiting, and the clues might be hiding where we least expect them. Music swells, then cuts to the series title card, Mindbenders. Part 2, The Cosmic Ghost. Music shifts to a slightly more investigative, mysterious tone. Narrator, VO. To understand the universe, we must first learn how to see it. For most of history, we relied on our eyes, then on telescopes that gathered visible light. We saw a brilliant, clockwork cosmos of stars, gas, and dust, all dancing to the elegant tune of gravity, a law laid down by Newton and perfected by Einstein. We thought we had the inventory of the universe more or less complete. We were profoundly wrong. The first clue that our cosmic census was missing something enormous, came not from what we could see, but from what we couldn't. It was a mystery born from motion. In the 1970s, astronomer Vera Rubin was studying the rotation of galaxies. According to everything we knew about gravity, stars on the outer edges should move much slower than those near the bright, dense center, just as Pluto orbits the Sun far more slowly than Mercury. But Rubin's meticulous observations showed something impossible. The outer stars were moving just as fast as the inner ones. The galaxies were spinning so rapidly they should have torn themselves apart, flinging their stars into the void. The only way they could hold together is if they were embedded in a colossal, invisible halo of matter, a substance whose gravitational pull was gluing the galaxy together. Rubin had discovered the first strong evidence for what we now call dark matter. It was a discovery that initially met with skepticism. How could the universe be dominated by a substance that emits no light, no heat, no radiation of any kind? A substance that passes through our planet and our very bodies as if we weren't even here. It was a ghost, haunting the cosmic machine. But the evidence kept mounting. We saw its ghostly signature elsewhere. Einstein predicted that immense gravity can bend the path of light, acting like a lens in space. And when we pointed our telescopes at distant galactic clusters, we saw just that. The light from galaxies behind them was being warped and magnified in ways that the visible matter simply couldn't account for. The lensing was being caused by vast, invisible clouds of dark matter, revealing its presence through its gravitational fingerprint. Suddenly, the universe looked entirely different. The brilliant galaxies we see are not the main event. They are merely the decorative lights strung along an enormous invisible structure. This dark matter forms a cosmic web, a hidden scaffolding that dictates where galaxies form and how the universe evolves on the grandest scales. It is the silent architect of the cosmos, yet we still have no idea what it is. Is it a new type of particle beyond our standard model? Does it obey laws of physics we have yet to discover? We have mapped this invisible empire, but its nature remains one of science's most puzzles. We are living in a universe built from a substance we cannot identify. And this raises an even deeper question. If the physical reality out there is so fundamentally different from what we perceive, what does that say about the nature of the observer in here, the consciousness that perceives it? Perhaps the first step to understanding this cosmic ghost is to better understand the ghost in our own machine. Music swells with a sense of deepening mystery, then fades. Music fades in, more intimate and cerebral than the previous cosmic score. It feels like entering an inner world. Title card, Part 3, The Ghost in the Machine. Narrator, VO. The cosmic ghost, dark matter, presents a profound challenge: to understand a universe whose fundamental building blocks are invisible to us. But the ghost in the machine, consciousness, presents a challenge that is arguably even stranger. It's not just invisible, it is the very act of seeing itself. It's the feeling of knowing, the experience of being. How does this happen? How does the wet, gray electrochemical hardware of the brain create the technicolor movie of your subjective reality? This is what's famously known as the hard problem. The easy problems, which are by no means simple, involve mapping the brain's functions. Science is getting remarkably good at this. We can put someone in an fMRI scanner and see which parts of their brain light up when they recognize a face, listen to music, or feel fear. We can correlate the firing of C fibers in the nervous system with the sensation of pain. We have drawn a detailed map of the brain's machinery. But a map is not the territory. Knowing which neurons are firing when you see the color red tells us nothing about why it feels like red. It doesn't explain the warmth, the memory, the sheer ineffable redness of the experience. The brain is a biological computer of staggering complexity. Nearly 100 billion neurons, each connected to thousands of others, forming a network with more possible connections than there are atoms in the known universe. It processes data, it computes, it reacts. But why isn't it all just dark, silent, unfeeling processing? Why is the light on inside? From where does the ghost emerge? One leading idea is that consciousness is an emergent property. This means it isn't a feature of any single neuron, just as wetness isn't a feature of a single water molecule. But when you get enough molecules together, behaving in the right way, the property of wetness simply appears. In the same way, perhaps when you get billions of neurons firing in a sufficiently complex and integrated network, the property of awareness simply appears. This theory suggests consciousness is not a ghost haunting a machine, but a symphony that arises from the orchestra playing in unison. It's a compelling, elegant idea, but it still leaves us with a deep sense of unease. Is it a full explanation, or is it simply giving a name to a miracle?
Would not only deepen the cosmic puzzle, but also begin to hint at an almost unbelievable connection between the two. The clue wasn't in how things hold together, but in how they are flying apart. For decades, cosmologists assumed the expansion of the universe, started by the Big Bang, must be slowing down. After all, gravity is the universe's great collector, pulling everything together. But in 1998, two separate teams of astronomers observing distant supernovae found the exact opposite. The expansion isn't slowing down, it's accelerating. Something is pushing space-time apart, a kind of anti-gravity woven into the vacuum of space itself. They called this mysterious force dark energy, and it is the dominant ingredient in our universe, making up nearly 70% of everything that exists. So now our cosmic inventory is even stranger. 5% normal matter, 25% dark matter, and 70% dark energy. We are adrift in a sea of unknowns. But here is where the story takes a turn, from a mystery of physics to something that borders on philosophy. When scientists calculated the precise strength of dark energy and the amounts of dark matter and gravity, they found something astonishing. These values appear to be exquisitely, impossibly fine-tuned for the existence of life. If dark energy were just a tiny bit stronger, the universe would have expanded so violently that stars and galaxies could never have formed. The cosmos would be a cold, empty, featureless void. If it were a little weaker, or gravity a bit stronger, the universe would have collapsed back on itself billions of years ago, long before life could have ever gotten started. The parameters of our universe are balanced on a knife's edge. If you were to represent all the possible values for dark energy, the range that permits life is so infinitesimally small, it's like throwing a dart at the entire cosmos and hitting a single specific atom. This isn't just a puzzle, it's what physicists call the worst prediction in the history of science. Our best theories predict a value for dark energy that is 120 orders of magnitude larger than what we observe. This discrepancy is a number so large it's difficult to even write down. So why is our universe so special? This leads to a controversial but provocative idea, the anthropic principle. In its weak form, it's a simple statement of selection bias. Of course, we find ourselves in a universe with life-permitting laws, because if the laws were different, we wouldn't be here to wonder about them. This suggests there could be countless other universes in a grand multiverse, each with random physical laws, and we simply won the cosmic lottery. But a stronger, more unsettling version of the principle flips the logic entirely. It suggests that the presence of observers, of consciousness, is not a cosmic accident, but a necessary condition for the universe to be the way it is. It hints that the cosmos is not just a stage for mind, but is somehow tied to it. This is a radical, mind-bending idea, that the universe and the mind that perceives it are not separate entities, but part of a self-creating, self-observing loop. What if the answer to the cosmic ghost and the ghost in the machine is that they are codependent? To explore that possibility, we must venture into the strangest realm of all, the quantum world, where the act of looking changes what you see. Music swells, a fusion of cosmic grandeur and intimate cerebral tones before fading out. Music starts with a strange, shimmering, almost digital quality, a stark contrast to the grand orchestral scores. It feels uncertain and mysterious. Title card, Part 5, The Observer's Reality. Narrator VO. The fine-tuned cosmos seems to whisper a strange secret, that our existence might be written into its fundamental laws. But to hear that whisper, we must leave the realm of galaxies and black holes and journey to a place far stranger, the very foundation of matter and energy. We must enter the quantum world. And here, the rules of reality as we know them are not just bent, they are shattered. On our scale, an object is in one place at one time. But at the quantum level, a particle like an electron can exist in a ghostly state of superposition, in multiple places at once, as a wave of probability. It is only when we measure it, when we look, that it is forced to choose a single definite state. This isn't a limitation of our instruments. It appears to be a fundamental feature of reality itself. And nowhere is this bizarre truth more apparent than in the most famous and unsettling experiment in all of physics. Narrator VO. It's called the double-slit experiment. The setup is simple. Fire particles, one by one, at a barrier with two thin slits. If the particles were tiny baseballs, you'd expect to see two simple bands on the detector screen behind the barrier, corresponding to the two slits. But when we don't watch which slit the particles go through, something impossible happens. They behave like waves. Each particle seems to pass through both slits simultaneously, interfering with itself and creating a distinctive pattern of many bands on the screen, a clear signature of wave behavior. It's as if the particle, when unobserved, explores all possible paths at once. But the true mystery begins when we decide to check. When we place a detector at the slits to see which path each particle actually takes, the magic vanishes. The very act of measuring, of knowing, forces the particle to behave. The wave of possibility collapses, and we are left with the two simple bands we would expect from tiny baseballs. This is the observer effect. Reality at its most fundamental level seems to respond to the act of observation. The universe is not a static movie we are passively watching. It appears to be an interactive process. This led one of the giants of physics, John Wheeler, a colleague of Einstein, to propose a radical idea, the participatory universe. Wheeler suggested that the universe, in some sense, comes into being through the act of being observed, that information and existence are inextricably linked. What does it mean to observe? Does it require a conscious mind, or just a simple mechanical detector? This is one of the most hotly debated questions in physics, but it pushes us towards a staggering thought. Could the consciousness that we find so mysterious, the ghost in our machine, be the very thing that collapses the quantum possibilities into the concrete reality we experience? Could the fine-tuned parameters of our cosmos be the way they are because they are the only parameters that could eventually produce an observer capable of looking back, and in doing so, making the universe real? We are left on the precipice of a philosophical abyss. The two greatest mysteries, the nature of the cosmos and the nature of consciousness, are no longer separate. They have converged. The question is no longer just what is the universe or what is the mind. The question has become, do they create each other? Music swells, combining the shimmering quantum sounds with the deep cosmic tones, creating a sense of profound, unsettling wonder before fading out. Music starts with a strange, shimmering, almost digital quality, a stark contrast to the grand orchestral scores. It feels uncertain and mysterious. Title card, Part 5, The Observer's Reality. Narrator VO. The fine-tuned cosmos seems to whisper a strange secret, that our existence might be written into its fundamental laws. But to hear that whisper, we must leave the realm of galaxies and black holes and journey to a place far stranger, the very foundation of matter and energy. We must enter the quantum world. And here, the rules of reality as we know them are not just bent, they are shattered. On our scale, an object is in one place at one time. But at the quantum level, a particle like an electron can exist in a ghostly state of superposition, in multiple places at once, as a wave of probability. It is only when we measure it, when we look, that it is forced to choose a single definite state. This isn't a limitation of our instruments. It appears to be a fundamental feature of reality itself. And nowhere is this bizarre truth more apparent than in the most famous and unsettling experiment. Narrator VO. It's called the double-slit experiment. The setup is simple. Fire particles, one by one, at a barrier with two thin slits. If the particles were tiny baseballs, you'd expect to see two simple bands on the detector screen behind the barrier, corresponding to the two slits. But when we don't watch which slit the particles go through, something impossible happens. They behave like waves. Each particle seems to pass through both slits simultaneously, interfering with itself and creating a distinctive pattern of many bands on the screen, a clear signature of wave behavior. It's as if the particle, when unobserved, explores all possible paths at once. But the true mystery begins when we decide to check. When we place a detector at the slits to see which path each particle actually takes, the magic vanishes. The very act of measuring, of knowing, forces the particle to behave. The wave of possibility collapses, and we are left with the two simple bands we would expect from tiny baseballs. This is the observer effect. Reality at its most fundamental level seems to respond to the act of observation. The universe is not a static.
The world is full of fascinating paradoxes, isn't it? We hope today's facts truly bent your mind. If you're ready for more daily revelations that challenge the norm, subscribe to Mindbenders. Don't forget to ring the bell so you never miss a new video. Until next time.